A contingency table is a tool that simplifies calculating probabilities, especially conditional probabilities. The table displays sample values in relation to two different variables that may be contingent or dependent on one another. In this example, all current-carrying wires produce electromagnetic radiation. High-frequency radiation is sometimes thought to be the cause of cancer, while low-frequency radiation is generally assumed to be harmless. The table below presents the results of a study in a large U.S. metropolitan area of 215 children who died of cancer and the frequency radiation produced by the wires outside the building where the children lived. So take a look at this contingency table. What you'll notice is on the far right, we have row totals, and the bottom we have column totals. Now, not all contingency tables will have these. Some you'll have to total them up yourself. So that's just a heads up that not all contingency tables have these totals already done for you, and you can just easily go ahead and do that yourself. So let's take a look at this first question. What is the probability that a randomly chosen child died of lymphoma? So what we are going to do is we're going to come to the lymphoma column, go down to our total, a total of 31 died of lymphoma. So the probability that a randomly chosen child died of lymphoma is 31 out of the total number of 215. Next, what is the probability that one of the randomly chosen children died from high-frequency radiation exposure? You can see we've got high-frequency radiation exposure here, a total of 79. So this would be 79 out of a total of 215. What is the probability that a randomly chosen child died of other cancers and had low-frequency radiation exposure? So there are 31 children who died of other cancers that had low-frequency exposure. So the solution is 31 over 215. Let's go to the next question. What is the probability that a randomly chosen child died of other cancers or had low-frequency radiation exposure? So here we need to use the addition rule, and it is, if you recall, the probability of A plus the probability of B minus the probability of A and B. So the probability of other cancers is 48 out of 215 plus the probability of low frequency is 136 out of 215 minus the probability of other cancers and low frequency. So other cancers and low frequency is 31 out of 215. And when you combine those together, you get 153 over 215 is the probability. So what is the probability that a randomly chosen child died of leukemia given that the child had high frequency radiation exposure? So this is a conditional probability. The sample space has been reduced to the children who had high frequency radiation exposure. So that's 79. Of those children who had high frequency exposure, we have to look at how many died of leukemia. 52 died of leukemia. So then the probability is 52 over 79, a possible 79. And lastly, what is the probability that a randomly chosen child had high-frequency radiation exposure given that the child died of leukemia? So again, this is the conditional. The child died of leukemia, so a total of 136 died of leukemia. And how many were high frequency? 52. So then it is 52 divided by 136. 52 over 136, that's the probability of randomly choosing a child with a high frequency radiation exposure, given that the child died of leukemia.